All right, hello and welcome. We're going to talk today about the system that I have built, which I call the Overkill1000D. Um, I have some pictures. I think we'll start with the pictures first, then we'll get into the finer details with system specifications. So to start off, the system is a Corsair 1000D. As you can see, there are a total of, well, 7 radiators, but there's 6 of the 480 millimeter radiators. There is 2 thick Hardware Labs radiators in the front, and then there are 4 thin of the Hardware Labs thin radiators that is mounted on top and also in the rear exterior of the computer case. I managed to be able to hold the exterior radiators together with the combination of parts. So as you can see in this picture, I have a coolant bracket, external radiator bracket that I bought from Newegg. And the really cool thing about the Obsidian 1000D case from Corsair is that there are mounting points on the rear of the case for both a 120 millimeter and also a 140 millimeter. So I thought, well, I could just take advantage of both. And what I ended up doing, I'm just going to zoom in here, is I had a 120 millimeter size for the bracket, and I had a 140 millimeter radiator that I managed to screw in. So basically, I'm using all the mounting points here. Now, I did try to fit a 280 millimeter radiator here, but I found that it just wouldn't clear, and it would also hit the bottom. Yeah, unless it would be some serious modification, cutting some portions to the top, but then I wouldn't be able to fit a fan in there. So I ended up just sticking with a 140 millimeter radiator here, and it works pretty well. So what I have this in use is basically as GPU heat exhaust. Um, the way that the loop is set up, I know this looks very confusing, but the front 2 radiators are the GPU radiators, and also the 140 millimeter radiator is part of that GPU radiator loop. So starting off, the system has 4 DDC pumps because they are power management controlled. They can be reduced to a very low percentage of power, and it runs very quiet. So there's actually EK X-top connected with a fitting, and there is a Fantex R220 radiator that is mounted. Now, the really cool thing about the Corsair 1000D case is I could actually fit 2, and it clears beautifully. So there is one loop that is only for the CPU, and the CPU is a Intel Core i9 7920X running at 5 gigahertz, which gets extremely hot, especially during benching. So I allocated 4 thin radiators for that, and I only have it in push. I only have it in push because when you have a very thin radiator, you don't really need to have push-pull, and it would be an unnecessary amount of fans. So the top is just a thin radiator with push configuration, and then there's also the rear external radiator that's also connected to the top. The loop order for the CPU loop is that first it starts off by cooling at the top because the temperature inside the case is a lot warmer. So the loop starts off by going into the very top radiators, and then it cycles through. Then it goes down, exits, connects to the external radiator where it has cold air. And just keep in mind that air outside the case is always going to be much colder, maybe by about 5 degrees centigrade or around that much. So I wanted to have the loop set up this way because I know the heat rises. Not as fast as people would think, but it does rise. And since I'm kind of blowing air upwards because these fans are sucking air upwards, that heat is exhausting up outside of the case. So that made it sense to have a good starting point. And then once it goes to the external radiator, the temperature gets much colder because obviously the temperature outside of the case is going to help. And so once it goes to the second radiator in the external radiator, that's when it shoots straight up into the CPU and it receives the coldest possible temperature. Now, keep in mind, this is, of course, ambient temperature, but still, any kind of temperature outside the case is much better than any temperature inside. So that was the main reason for doing that. And because it's 4 pumps, it shouldn't be that much of a problem with restrictions. And I actually managed to fit this pretty well. I mean, with all of the connections, it manages to just perform so quietly. I could run the fan speed at 800 RPM. The Hardware Labs radiators are designed for 800 to 1000 RPM. And of course, for benching, I just turn it up to 100%. But I'm pretty happy with the way this turned out, because I could have mounted it maybe at the bottom, and that would have required screwing it down. In this case, it's already screwed onto the front rads. So it looks pretty good because there's a side view mirror. So yeah, that's pretty much the setup. Now let's move into some more pictures of the build. Okay, so as for the GPUs, I went with 2 Galax OC Lab editions. It was hard to get the second one because honestly they only made 100. But I managed to find someone who sold one, and luckily I was able to pay the amount and have it shipped. So luckily I got a second one. Now Galax does have 2 brands. They have the Galax, which is well commonly known in the United States. They also have the KFA2. And the motherboard, I got a really good deal, and a huge thanks to EVGA, by the way, because this motherboard, it does everything you want it to do as far as overclocking. And if you wanted to just overclock on its own, it does that too. So let's take a closer look here. I'm running DirectDi. So the CPU, it's a bin CPU. It was binned by Extreme Overclocker, and according to what I've heard from the seller, is that he had 20 of these CPUs. He sold me the fastest one, basically, which is why I'm able to hit the 5 gigahertz. So it has the Bowers DirectDi frame. The CPU, I cleaned it off pretty well, and I also applied some nail polish, clear nail polish. I applied 3 coats, waiting 20 minutes in between each coat for it to dry, and that prevented any kind of shorts around the SMDs. The CPU die has liquid metal, and I did not do any kind of lapping on the die. That might be something like for Buildtoy, but I'm not gonna risk just grinding through the entire silicon and killing the chip. So yeah, it has also 4 DIMM slots, so I decided, why not just populate those and go high capacity. So it has 2 of the G-Skill Trident Z Royal. These are 2 by 16 gigabyte sticks. It's rated out of the box. It's rated for 4000 megahertz CL19. I couldn't quite get it to 4000 megahertz. I think one of the RAM sticks just wasn't binned high enough, because I could see the troubleshooting LED in the RAM, and that indicated that it just wouldn't boot. Whereas the other 3, they were capable, but I wasn't really kind of in the mood to like buy another kit, just in the hopes if I could get one more that would run the 4000 megahertz. X299 Dark can already do very, very well at 3800 megahertz, which is what I was able to clock it at. And also I managed to go 2 CL lower, so I went from CL19 to CL17. I thought that was a pretty good trade-off. The other thing that I modified is I added a Wi-Fi card. So not a lot of people do this on X299 Dark, by the way, but since it is going to be used for gaming, and actually just recently Sennheiser released the Bluetooth headset, which is going to come out soon for about $250. Now it kind of makes sense because right now I'm using just a wired headset, but I plan on getting one of those later on. So it has an Intel M.2 card, which you can see it's installed here, right? And in this part, it also has little connections for antenna. The antenna connectors did not come with the Wi-Fi card, the M.2 key. I actually have to buy those separately off Amazon, but they did screw into the I/O and the antennas were secured. So I actually tested this because I tested the Wi-Fi with the antenna. I get very good signal bars. And let's see what else. So moving on to other parts of the computer. The computer is using a Aqua Computer Creos Next Vision with Vario adjustment. So this water block is a nickel top. Underneath there is a silver base plate, which is sterling silver or 0.925 silver. Now, as far as conductivity, silver is pretty high in terms of conductivity, so I made sure that I had to get a very good thermally conductive material. I've heard that it's actually slightly better than copper, but maybe forged or pure copper could be better. But I really wanted to have something that would match also the color of the RAM, and this does that pretty well. Also, the LCD screen, it lights up. It is fully configurable through software. You can put temperatures. You can put the temperatures of your GPUs. It's connected with a USB cable. So that is a really good water block. And I also put liquid metal on the base plate. So the base plate, the really cool thing is that you can actually adjust it. So there's Allen keys on the left and top part. So what that allows you to do is you can lower it by 200 micrometers on top of what you already screwed on the CPU water block itself. That lets you get an extremely tight contact surface, and it helps with your core temps. I actually tested this using Intel burn test, and I was able to go maybe 10C lower, and there were very little thermal throttling at 5 gigahertz. All right, moving on. I also modified I really went crazy. This is probably unnecessary, but I really wanted to have an extra VRM fan. Now, of course, people are going to say, well, rip your warranty. But honestly, the board, I got it on Black Friday for $250, which I thought that was a pretty good deal because now the board is twice as much. So a huge tip to anyone out there, if you want to buy a motherboard, do it on Black Friday. You'll save yourself a ton of money. And the fan here is a Noctua fan. Apologies to Noctua, but your fans just simply did not come in black. That was a huge turn off. So what I ended up doing, even though it probably affected the airflow slightly, was spray paint the entire fan black. And now it actually looks pretty good. And also, I had to cut out the plastic covers of the BRM so that air could actually penetrate. So you wouldn't kind of notice that stock, the VRM would have this dark plates on the bottom, so I had to cut that out. But I still didn't want to lose the identity of the board, so I actually positioned that on top of this fan. Now with 3 fans, there's no problem with any temperatures. I mean, it already didn't have any, but this is kind of like overkill. As far as monoblocks, just in case you guys are not aware, there are no monoblocks available for this particular motherboard unless you CNC one, which I don't have a CNC machine. Or even custom job, but no, I mean, I think this is really enough, and it runs pretty quiet. So yeah, that's part of the modification that I did. I added a third VRM fan. All right, so moving on. The GPUs, I did flush them with Blitzkit Part 2. So they are very clean. It took an entire day to get this process done because it's like a shampoo kind of cleaning solvent. I had to do both of these. So that's why I had to order the soft tubing. Hard tubing will be a thing. It's just not right now. Soft tubing and the fittings are just so effective in terms of cost. I didn't have to spend a lot, and it got the computer up and running, so that was great. Moving on, so the way I managed to flush it was I had to get a jumper. Let me just rotate so you guys can see. All right, I'm gonna zoom in here. So yeah, there's an EVGA 1600 watt power supply T2, which huge thanks to EVGA. You guys on your Black Friday deals, man, this was like a steal. I mean, I got it for a really, really good price. And there's a jumper, 24-pin jumper. You can see the button right there. I used that to turn the power supply on. So it didn't actually have to be connected to the motherboard, although I did use the motherboard as a mount so that the GPUs would not move around. So I flushed pretty much everything with parts 2 of the Blitz kit, and the radiators also sat in part 1, and they were rinsed out, of course, you know. So I took care of all the issues with any kind of dirt out of the factory and the rads and stuff like that. Okay, let's move on to storage. Storage is pretty important. For storage, I decided to go with 2 Samsung 970 Pro M.2 NVMe's because there were 2 slots available, and I could have gone with the Evo, of course, but the 970 Pro is much faster than the Evo. Now, I would like to think of the Evo being like a submachine gun, whereas the 970 Pro, that's your 50 caliber machine gun. So it just keeps consistent speeds, and game times for loading are just extremely good. I managed to get these on heat sinks, which I'll show you right now. Excuse me. So for the heat sinks, let's take a look. Let's see where. Here you go. So these are Aqua Computer heat sinks, Cryo M.2s. They actually didn't quite work on the vertical because I couldn't see the GPU. The heatsink fins actually prevented the graphics cards from clicking, so I had to file those down. You can kind of see it right here in this picture. So without any kind of modification to the heatsinks, I couldn't get all the entire PCIe fingers to click, which is why modification had to be done to get those to see properly. Once modification was done, then the GPUs clicked all the way, and I covered up the excess with some electrical tape because there is a PCH fan and at least some kind of coverage so that the air will be trapped inside and still continue on through the other channels, but that was pretty important. I didn't want any air to leak out. So the temperatures are still pretty good because there's a heatsink, there's air going through the heatsink. That works great. All right, let's see. Oh, this is just a picture of the RAM. So the RAM is Trident Royal. Yeah, it looks great because it has RGB. But I really just got it for the speed because it overclocks very well. And it's Samsung B die, so that's pretty good. You might be looking at this video in the future and you might think, oh, well, Samsung B die is no longer in production. That's true. There's Samsung A die. At the time of this video being recorded, I'm not sure what the specs. There's no spec sheets for A die, but that's the replacement. Now, moving on to the GPUs, this is kind of the fun part. So, out of the box, the Galax OC Lab Edition comes with a water block. They also include thermal pads, and they also include gloves. They also include this EVBot kind of connection for the end. That allows you to do certain things like PLL voltage control. That will be pretty useful for benching like under LN2. I don't have any LN2 containers with me right now, so that might be a feature for the future. Moving on to the board. So there are jumpers. Excuse me. There are jumpers around the board that can be removed. That I believe removes voltage limitations. I haven't tried it yet. I will once I replace a few LED lights on the block, because I will be doing a mod just for aesthetics. And what I did with the GPU, pretty much the same treatment as the CPU. the CPU, of course, had the nail polish, so I applied nail polish around the GPU die. It was 3 layers, waiting 20 minutes for it to dry. Then I applied the thermoglissy conduct knot. Now, in case you guys are wondering what nail polish I used, I used the Sally Hansen Top Coat Color Therapy. It is non-conductive because I can swear to you, my GPUs are just doing just fine. And the way I managed to know which one to use is because during a Gamers Nexus video, huge credit goes to Steve Burke. Steve Burke used the exact same nail polish. And what I did is I managed to just pause the video, zoom in, look at the make and model of this particular one, and look it up on Amazon, so I ordered that one. And I kind of already knew that it worked for Steve, so it could work for me too. All right, moving on. So after it dried, I applied the conductor knot pretty evenly. And then I applied the thermal pads. Thermal pads took some time. And then there's so many screws. Luckily, they include tools for adjusting the screws. So that was the GPU. Excuse me. So moving on, let's see what else can I show you. Let's see. Actually, I think we're kind of done. Wow, that was very fast. So installed. This is kind of how it looks like. Of course, there is no cables here. There will be custom cables eventually. I don't plan on buying pre-made ones. I plan on actually getting spools and cutting and soldering it myself. That will be probably Q3 2019, but it will happen, of course. So the GPU water block is by Bitspower. Now there are 3 8-pin connectors. As far as the maximum wattage, it can go over 500 watts. I've got a custom BIOS in it. And with that, I think we're ready to go into the specs. So let's get into it. So we're going to go into numbers now. Okay, so I'm going to close this out. All right, so first off, there is a custom BIOS, which I got from Tech Power Up. So I flashed both cards with NB Flash. And both cards are now at maximum 450 watts. Default 400 watts, which I know is pretty high, but honestly, for 3 8-pins, that's actually normal. These are 2080 Ti's, and made by Galax, of course, because it says Galaxy there. It has 2 GPUs, so NVIDIA NVLink is enabled. I managed to get a 4-slot, which allows 16x, 16x. Core i9 has enough PCIe lanes to do 216x. And I think that's how you really should run these cards, because if you go 8x on these, you're just undercutting the true performance of the card. I mean, why are you doing that? So I decided to go with a motherboard that is HEDT, high-end desktop. And yeah, you can actually see here, I have a GPU monitor. It says PCIe link with 16x. 16x. Let's take a look at the hardware monitor so we can look at some temps just for idle. So where are you, hardware monitor? Let's see. It's one of these. No, it's RealTuner, Afterburner. Sir, it was just here. Come on. Where are you? Where are you, hardware info? Let's check. Do a search. Hardware info. Man, it was just here. Like, okay, let me check again. Is this it? Oh, that's core temp now. I think it's HW info. Yeah, there it is. Okay, sorry about that, guys. All right, let's run it. And detecting. Okay, cool. Close. No, I do not want to update. Okay. So let's take a look at the sensors. So temperature-wise, I am running a very high vCore, which honestly, I know that's very high. People will kind of cringe. They'll say, you should just run it at 1.35. 5 gigahertz will not boot at 1.35. 4.7 will. But if you want to go higher in frequency, I have to turn up the voltage. And I actually didn't manually set this voltage. I've tried many times, and it hasn't worked. The voltage was automatically set by the motherboard, and the vCore is set to auto. So no issues with that. If the CPU degrades, honestly, I'll just buy another one. I think by the time it degrades, we'll have maybe another high-end desktop chip from Intel, which I think there might be a refresh in Q3 or Q4 2019, and there might be a replacement 2020. So we'll see about that. That's honestly the least of my concerns. But anyway, it is temperature-wise, it's doing pretty well. Idle temps are in this column right here in the current. So there's nothing above 60. It'll probably hit 55 in the course, but it won't go past 60 at idle. Now during benching, it might go up to 81. It might even go a little higher than that, but because I've set the water block to be as flat as possible without any lapping, it does pretty well in temperatures. Everything else is pretty much set to auto. Mesh is 30. I've tried 33 mesh, and then Windows corrupted itself. So yeah, it's going to stay at 30. And let's see, what else can we show you? Okay, as far as overclocking, the really cool thing is that I can set GPU voltage with Galax Extreme Tuner. So it can go as high as, say, 1.25 volts, which is pretty high. In gaming, I'll just set it to maybe 1.1 volts or 1100 millivolts, and that's pretty much a good voltage. I haven't had any issues with it. And CPU offset 148, I find is the most stable in most games. Anything higher than that, I don't think honestly it's the GPU's fault. I think the game engines themselves just can't handle it. So I have the memory clock offset at 355. It is not Samsung memory. I think this is micro. The other memory manufacturer, Micron. Yeah, Micron. And anything past 400, you start to get issues. I mean, maybe for benching it's okay, but for long-term gaming, I keep it at 355. So let's just overclock this real quick. We'll apply a medium overclock, 148, and let's see, apply. So apply. Okay, so that brings us to 2,115 megahertz or 2.1 gigahertz. If I switch over, oh, by the way, I have applied these settings to both in Extreme Tuner. If I switch over, you'll see that it's the same. So the frequency is matching. So that's great. Let's go over to hardware info. Oh, it just hit itself again. Let's see. Oh, did you? Yeah, here it is. Okay, so let's go over to GPUs. Okay, so you can see right there. GPU clock, 2,100 megahertz. GPU memory clock, 7,355 megahertz. And GPU voltage, that I don't think it's true. Maybe it could be the jumpers that I have to remove. That probably could be limiting it, but it's at 1,100, which is it's fine. Honestly, the temperature is fine. All right, so let's do some tests because I know you guys really want to see what this thing can do at 5 gigahertz with two 2080 Ti's from Galax, right? So I am currently downloading a lot of benchmarks. Some are installing. The ones I can show you right now is just Timespy Stream, and I can run that right now. Port Royal, it's installing, so maybe tomorrow for another video. The video is already getting kind of long. I apologize. Let's run Timespy Extreme, and again, we're at 2,115 megahertz. It could go higher, but we'll start this as a base test. So let's see, custom run. Graphics test 1, yes. Graphics test 2, CPU test, yes. Let's see, looping enabled, no. We'll do 4K. Demo VRAM. I'll just set it to auto. Let's see, CPU instruction set auto. VSync enabled, no. Absolutely not. So no fixed FPS. I wanted to just run with all the FPS without limits. So let's just run. So let's see. All right, my first Timespy Extreme benchmark run. Here we go. Go away, MSI Afterburner. Don't need it right now. All right, here we go. Oh no, it's loading. It's loading though. Oh wow, we're over 100 FPS. And keep in mind, this is a 4K resolution, by the way. We're dropping some frames here. 60 FPS. Looks really great. Alright, we're dropping a lot of frames. We're at 29. Let me see if I could do MSI Afterburner overlay. Yeah, we can. So there he is. Alright, based off the MSI Afterburner overlay, I can see that the GPUs are at 35% utilization. But we can tell right away that NVLink is working, otherwise we wouldn't be able to see utilization on both. Now that's my, if you look at the top left of the screen, that's my third and fourth row. Temperatures are at 40°C, 6 radiators. That's what we're gonna get with 6 rads, man. Well, 7 with the mini 140 rad. CPU temps are in the 60s. Cool. That was good. I think that was GPU test 1. We'll go to GPU test 2. Oh no, this is still 1. Okay. I kind of wish they should make this into an actual game so you can just wander around. That'd be cool. All right, so temperatures are still 42, 43. Also, by the way, I haven't actually upped the fan speed on the fans. This is just regular gaming mode. So the fans are doing about 800 RPM on all fans. There's about 32 fans total, and they are Corsair ML RGB fans, maglev. This one's pretty silent. But we're still getting 100 FPS. Also, I think that's something I have to invest in the future is getting one of those BFGD displays because I am using a TV, and the TV is limited to 60 hertz. So that's kind of very limiting. But anyway, it was only like $350, so that was pretty good just to get it up and going from Fry's Electronics. All right, so we're at 2100 megahertz. GPU temps are 45. See, I do not have any kind of air conditioning, by the way. There's no air conditioning here, just ambient temperature in Southern California. But as far as the graphics, I mean, it looks great. It looks really good. And FPS max is around 110. FPS lows is around, I would say, 30 on some scenes. I think it's going to get a very good score, to be honest with you. Also, as far as just RAM usage, I'm only using about 12 gigs of RAM out of 64. So it's way, way overkill. All right, this is CPU tests. Let's go. Let's see those CPU temps. All right, let me get the overlay up and running. Oh, it's not. I can't show it. Oh, there it is. Okay. All right, so 12 cores with hyperthreading. Temps are now going up to 60s, high 60s, 70s. But it's not going over 80. So there is still no. Oh wait, I saw 83. So 83 was kind of the max I just saw right now. But it's not going to 90. That's for sure. It's not going to 90, and I have a very quiet fan speed right now. I'm at 800 RPM. Getting about 9 frames per second just with CPU. You can tell that the GPUs are not doing anything in this scene. I'm seeing the overlay on MSI Afterburner. GPUs are at 1% utilization. So this is all CPU, by the way. So do not think for a second that the Galax Hall of Fame cards are giving this performance, because it's not. It's all CPU rendered. Even the GPU temps are at 36C. So that was entirely CPU. But at 12 cores, 5 gigahertz, that honestly wasn't bad. It was pretty good. It's got 4 more cores than a 9900K. Admittedly, though, a 9900K can go 300 megahertz faster. So, all right, so we got a score of 14,770 for graphics. So that's pretty good. Graphics test 1, we did 92.84 FPS. Rounding it off, I would say 93. Graphics test 2, we got 87.53 FPS. Not bad. CPU score, got 5,024 points. Average simulation per frame, 69.7 milliseconds. Let's just show the settings used, by the way. It was rendered, this was rendered at 1920 by 1080, really? Because I set it to 4K. That's weird. I thought it was 4K there. That can't be right. Anyway, GPUs, 228 Ti's, NVLink, Intel Core i9 7920X. Today's dates, cool. I mean, that was cool. So let's see, monitoring. This is the timeline. And let's see, compare results online. I want to save this, actually. I want to save this score. I'm going to save it as 3D Mark first run Timespy. All right, cool. Saved it. And let's see, compare results online. I think that's one that tells you how good your build is compared to others. Let's check. Oh, I got to register. All right, well, we'll do that later, I think. Yeah, let me just move this over. Okay, so we got a valid result. Let's see. Where's the one that tells me what my computer is better and stuff? So, let's see tells. Let's see, valid results. Add to compare. View benchmark run. No, I just want to see if this is better than everyone else in the world. Okay, let's see. Valid result. Yeah, Hydra. That's what I'm trying to find. Is it add to compare, maybe? So I got a score of 1100, 440. Okay. Search with same GPU, search similar systems. I think those are LN2 scores. Anyway, that was a first run, which is not bad. I will register for this later. Let's see. To submit scores to Hall of Fame, you need to create a feature mark account. So I'm going to pause the video here. I hope you guys enjoyed the video. I am still waiting for the rest of these benchmarks to install. So we'll do a follow-up video on those. And give a like if you like the video. Subscribe. There'll be more content in the future. And yeah, thanks for watching this video. Bye.